Welcome back. Let's have a look at our next topic in this section. Sometimes we want to determine the value of an annuity, not at the end like we've just done, but at the beginning of the payment stream. So the formula we've learned so far gives us the value at the end, or maybe how much we would accumulate over time. What if we want to know the value at the beginning? A good example of that would be I want to set aside some money now so that I can have payments of $500 a month for the next 10 years. Maybe that's something I want to do in my retirement, for example, have a little extra for 10 years. How much should I put aside today? Well, I won't have to put aside the full amount that I'll be withdrawing because I'll be earning interest, won't I? Well, that value at the beginning of the term is called the present value of the annuity, and that's what we want to learn to calculate. Remember, with ordinary annuities, the payments are at the end of each period. So if I do a timeline, I say here we are at the beginning, and let's go out to the end. When I put the money aside, it's right at the 0 mark, isn't it? That's not where the first payment is. First payment is at the end of the period, but the present value is at the very beginning of the period. Now here's a formula we can use. It's very similar to what we had for FE, but I've switched around the numerator here inside the square brackets, and that's 1 minus 1 plus I to the power of negative n. So just like we had with compound interest, when we're going backwards in time, we have a negative value for n. Let's see if we can try it out, put it to work. Peter would like a monthly retirement income of $3,000 at the end of each month. How much would he have to have in his retirement fund when he retires, so at the start of his retirement, in other words, in order to provide that $3,000 a month for 25 years? And let's assume that his account earns 6% compounded monthly. I'm going to start just by writing a few things down. The payment that we want is $3,000 per month. We want that for 25 years, and we want 12 payments per year. 25 times 12? 300. So we want 300 withdrawals from this account. The interest rate per period, little I, 0.005. That's just the way we always get it. Divide the 6 by 12. And we want to calculate the present value. So let's put that down with a question mark just so we make sure we pull out the right formula. In this case, the formula we just learned, present value, payment, multiplied by 1 minus 1 plus I to the negative n over I. With our values, we'll go and substitute those in. 3,000 times 1 minus 1.005 to the power of negative 300 divided by 0.005. If I go and work that into my calculator, I end up with $465,620.59. So that's how much he's going to have in his account on the day he retires if he wants this to all work out. Let's look at something interesting here though as well. He's getting 300 withdrawals of $3,000. He's getting 900,000 back out. Where did the extra money come from? Because he only put 465 in, he's getting 900,000 out. Well, the extra money that he's taking out is interest, isn't it? So he's earning interest along the way, and that's going to give his account a big boost. So that's one of the nice things about a situation like this with retirement or any kind of annuity that's going to pay you over time. You're getting not only what you put in, but you're also getting interest on your money too. Let's try one out, see if it works for you as well. What price would you be willing to pay today for an investment that guaranteed payments of $500 at the end of each month for 10 years? And let's use a discount rate or an interest rate of 6% compounded monthly. So go ahead and pause the video and try it out, see if you can do it. And then when you're ready, come back, press play, and we'll see how it went. All right, so I'm going to start again by writing down the basics. So we want payments of $500 for 10 years. That's 120 months, isn't it? And we're working in months this time. And the interest rate, 0.005. And I want to know how much should I pay today in order to receive that. Well, we'll pull out our formula. PV is payment times 1 minus 1 plus I to the negative n over I. Let's go put the values in there. 500 times 1 minus 1.005 to the negative 120, all divided by 0.005. And if you got this entered into your calculator correctly, you should have ended up with $45,036.73. So we'll go ahead and put 45,000 in the account or pay for that amount for it today. And then we get 500 a month for 120 years. If we go and we just check on that, we're going to get 120 payments of 500. That's $60,000. So you can see even in a shorter term one like this, we're still earning a bit of interest on top of our 45,000. Well, that's it for the present value of an annuity. Go ahead and try some of these out. And when you're, try some from the book first and that sort of thing. And when you're feeling comfortable with them, go ahead and move on to the next section. Bye for now.